Okay, today we're going to be implementing a backup solution that's customized using Snapshots, pigz, tar, and SCP to get our backups over to a remote destination. And we're going to be backing up our Ubuntu 21.04 server and sending the backups over to a TrueNas server. So how we're going to do this is we're going to use our snapshot skills that we learned in the last video. We'll take a snapshot, we'll mount that snapshot to a mount point. We will then use tar and pigz to back up that snapshot to another directory. Then we will send that backup to a remote destination server, which is a TrueNas server, so that it is safe and secure on another machine that is remote. The cool thing about these backups is that they're incremental, so the initial backup will be larger, but subsequent backups the next day or the next hour or the next week will be very small and only contain the changes that we've created since the initial first backup. So we'll need another application that typically doesn't come installed on Ubuntu 21.04, and that application is pigz. So let's go ahead and download that now. And what pigz does is it allows tar to run compression with parallel CPU. So the compression task goes much faster, therefore the backup will also go much faster. Without pigz, the backup takes about 7 or 8 minutes. Once you have pigz installed and run it along with tar, the backup runs in less than 1 minute at the cost of your CPU processing power. And at the time that these backups are going to be running, I'm not too worried about the CPU resources being used at 4 a.m. So let's switch over to root users so that we don't have to enter sudo for every command. Then we'll do a quick apt install pigz. We'll let that download and install. Okay, so now what we'll do is we'll generate an SSH key so that we don't need to use a password when we connect to our remote destination server. Okay, so we just use the command ssh-keygen-t for the type of key, which is going to be an RSA key. Okay, so the key has been generated. I've already generated a key previously, so I'm going to say no to overwrite. Let's take a look at the keys. So the two keys that we are concerned with right now are id_RSA and id_RSA.pub. This is the key that we are going to provide to our TrueNas server. And the id_RSA is our private key, which we will keep secured away on our server here. What we can do is share our public key over to our destination server. And when we connect, we will use our private key. This will authenticate us and it will not require a password for us, and that way we can automate this. So let's add this public key over to our TrueNas server. Mind you, the TrueNas server may need some configuration on the TrueNas side that you'll have to do on your own. That's not part of this video. Essentially what you need to do is you need to make sure that the user that you're adding this to has a home directory that is writable. By default, TrueNas doesn't have that. I have configured that. It's pretty easy. You go into the user, you select home directory, and you apply a home directory for the user. So to add the public key over to the TrueNas server, we can use the command ssh-copy-id with the -i flag. Then we'll specify the location of the .public key, which is in /root/.sh/id_RSA.pub. Then we enter the user for the TrueNas server that we want to use to send the backup files to, and the address of the machine. So you see here I get a warning that the key is already existing. on the TrueNas server, which is fine. I've already applied this. So now we can go ahead and we can create our backup script. So I'm going to create the script in the root directory of the server. So let's go do that now. So I'm going to use VI to do this. It is the classic text editor for Linux. It's the one I've used and the one I'm used to editing in. You can use Nano or any other text editor that you have. So we're going to start off here. This is going to be a bash shell script. So we'll do pound bang bin sh. We'll create some commented outlines at the top just for notes about what this script does and any extra information that we want to add later on. So here in the top box, I'm just going to put in what the script is. So it's a backup script using snapshots and SCP. So let's start off the script with the variables that we're going to need for the remainder of the script. These are going to be some commonly used entries that we don't want to repeat or we want to shorten. So the first one's going to be include. This is going to be the directory that we are going to be backing up. It is going to be the directory that we mount our snapshot to. So this is going to contain all of the data that the snapshot contains and also the source directory for tar. The next variable is going to be exclude. There's going to be a lot of directories that we don't want to have backed up or files that we don't want to have backed up that would either slow the backup down or are just unnecessary. For instance, we don't want to back up our swap file. It's not necessary for a backup. It can grow up to about 4 gigabytes and we don't need to include it. So we'll use an exclude flag here to exclude the swap file. So we can easily do that with a -- exclude equals / We're going to put in BKP because that's the directory that we're getting this from. It's where our snapshot lives. So / BKP / swap.img. Then we can go on to the next exclude with the same syntax. That's -- exclude equals, and we can include directories like our temp directory. So / BKP / temp. We'll also include other directories here, such as / proc, which is our processes, / dev, which is our devices. We don't need to scan through those directories to back them up, so we'll put them in the exclude list. So for the next variable, we're going to use our destination. This is where we're going to place the backup file. So typically you'll have a secondary disk or another partition on another disk within the system. In my case, I will eventually have a disk in the mount directory that's mounted to the server. So we'll put this destination as / mount / BKP. So the next variable we're going to use is to be able to identify the system. So I have multiple systems performing backups that will all land in the same remote destination. So I want to be able to identify this machine, and we'll do that using the host name. We'll do that using the hostname variable with the hostname command with a -s, which is, to simplify it, it's not the fully qualified name. The next variable we're going to use is the date. So I'll use the variable day. We're going to put in the command date plus, we want the year, we want the month, and we want the day. And then we'll do dash and we'll do time, which is %H, and we're going to use a capital H to use 24-hour time as opposed to 12-hour time, and then the minute that it currently is. So we'll use this to identify when the snapshot was taken or when the backup was taken. So the next variable we're going to have is the file name for the backup. So I'm going to call this archive_file, and it's going to be a combination of backup, the host name, and the day, and then we'll add the extension .tar.gz so we can identify what type of compressed file it is. So we're also going to use a variable for the volume group. It's going to get used quite a few times throughout the script, and we don't want to have to type out the full volume group label every time. So vg equals dev/Ubuntu vg. Then we'll identify a variable for our snapshot name, which is going to be bkp snap, then the date. So the variable day we'll use. So each time we do a backup, it will have a unique name for the day and time that the snapshot was created. And if one gets stuck, we can identify how long it's been there and when it was created. So now in this section, we will start our backup script. So the first thing I want to think about when I run this script is to make sure that there isn't any previous snapshots currently mounted or currently in the volume group, because we don't want to run into issues later on with the volume group becoming full with too many snapshots and the backup failing. The first thing we're going to do is check for previous snapshots. And we can do that using a simple if, then, and else statement. So what we'll do is we'll do an if statement. We'll say if LVS, then we'll grep LVS for bkp snap, because we know that our snapshots are going to be created with the name bkp snap. And we'll just dump the output into dev null. We'll forward it to dev null because we don't need to see it. So if this if statement is true and we get a result, then we'll echo out to the output, a previous snapshot was found, and we will attempt to remove it. So we don't want to attempt to remove the snapshot if the snapshot is currently mounted to our mount directory, which is going to be /bkp. So we'll echo another line saying that we're going to check and see if the previous snapshot is mounted. And again, we can do that with an if statement. So we'll do df and we'll grep bkp snap. So if there's a mount point using bkp snap, which is the logical volume that we created the snapshot on, then we'll echo the snapshot is mounted, and we'll attempt to unmount the snapshot. So we can do that with a umount, and we know that our mount point for our backup snapshots is going to be /bkp. And then we'll allow 2 seconds for it to perform the umount. Typically it will be much faster than this. It's usually pretty instant, but once in a while you run into a situation where it takes a second or two. So after the 2 seconds, we'll check again if the mount point is still mounted. And if it is, then what we'll do is we'll give up on the backup. So we'll echo out, unable to remove or unmount the snapshot, and we'll exit the backup. And we can exit the backup with just a simple exit command. Now, if it's not still mounted, so if we were successfully able to unmount it, then we'll do an else, and we'll echo out snapshot unmounted, and we'll proceed with attempting to remove the snapshot. So we can remove the snapshot with a lv remove. We can specify the volume group with the variable we created, and then /, and the snapshot name isn't going to be the same as the current snapshot, so we can't use the snap variable. So we'll use a command. We'll do lvs pipe to grep, which will find a logical volume line in the result with bkp snap. Then we'll pipe that over to awk, where we can get the very first column, which will be the name of the snapshot. So awk will open a single quote, print, and then the cache sign and number 1. and then we'll close our single quote and we'll close our single bracket. And then we'll put a -- yes on the end of this because we don't want it to prompt us to confirm if we want to remove the snapshot. And then we can end this if statement with an fi. And then we'll do an echo and we'll verify that the snapshot was removed. So to verify that the snapshot was removed, we'll do another if statement. So if LVS, which is our logical volume show, we will grep bkp snap, and we'll send the results out to dev null. So if we get a result from the command lvs grep bkp snap, then we know the snapshot is still mounted. So we'll know if it hasn't been removed, and we'll want to know about that. And at that point, we would halt the backup. So we'll do echo snapshot not removed, halting backup, and then we'll exit the backup. We'll finish up with that one with an fi. Okay, and then we'll finalize our overall check for snapshots with an else. And we can echo no previous snapshots found. And then we'll finish up our overall if statement with a fi. So now that we've checked for previous snapshots, we will start our backup and we'll echo that out to the screen with backing up, and we'll provide the variables for the mount point and the snapshot and the destination. So now we can go ahead and we can create our snapshot. So lv create -l. So for this machine, the volume group is pretty small, so we don't want to exceed the size of the volume group, but we want to contain as much of the logical volume as possible. So we're going to try and match the size of the logical volume, which is currently 20 gigabytes. This will help us avoid situations where if the snapshot doesn't get removed because the machine crashes, there's a power outage, or for whatever reason, the snapshot doesn't get removed by the end of the script, we can avoid issues with the snapshot becoming full because it is at least the same size as the logical volume. So after we specify the size, we specify a -s for snapshot, -n for the name, and the name is going to be the variable that we created up top, which is snap. And we're going to be taking the snapshot of the source logical volume, vg/, which is the variable for our volume group, and then / Ubuntu LV. So once we issue that command, we'll give it 2 seconds to process that. So once we've created this snapshot, we'll confirm that it exists and is there after 2 seconds. And we'll use the command from above. LVS will grep the snapshot name. And we'll send this out to dev null because we don't need to know the results. And if the if statement is true, then we know that the snapshot is there and we can attempt to mount it. So we'll put an echo there saying that the snapshot was found, and we're mounting it to the / bkp directory. And we'll use the include variable to specify that. So we'll include the volume group as well. It might be useful information to see on the screen, to see the volume group and the snapshot name, and to which directory it's being mounted to. So in the scenario where the logical volume isn't found yet, we will output that to screen saying that the snapshot isn't found. And then we'll sleep for a couple seconds, just in case the snapshot's taking its time to become available. It happens, not very often though. So after a couple more seconds, we will test again for the snapshot. If it is still not available, then we will exit the backup. If it is available, then we'll go ahead and we'll attempt to mount it. So we can check again and we'll say echo mounting the snapshot. And we'll just use the same echo from up above. Oh, and I noticed here that we didn't include our mount command. So let's do that. So mount our VG variable and our snap variable, which is going to be the snapshot, and we're going to mount it to /BKP, which will be our include variable. And then we'll do the same thing down here. We'll use the same command. So if it's not found, then we will want to output to screen that the snapshot was not found or not created. It had failed for some reason. So we're going to halt the backup. So let's do that with an echo and then just an exit statement. And then we can go ahead and finish up our if statement with an FI. So after this check here, we should have a snapshot that is mounted to the correct location. So now we can start our collection and compression of the snapshot directory. So we're going to do that using tar. And then within tar, we're going to tell tar that we want to use a different compression application. And we do that with the -I. And the compression application that we're going to use is the pigz that we installed earlier. Then we'll continue with our regular tar flags. So -C for compress, -P for permissions. We want to preserve those. And G, which is going to indicate that we want an incremental backup. And the -G flag requires that we provide a file to store the incremental change data. This is the metadata for those changes. So here we'll put it with our backup files. We will use the variable dest, which is our destination, and then we'll name the file bkp.snap. So for tar, you need to be mindful of the order that you put your includes and excludes. So excludes come first. If you don't put your excludes first, they will be ignored. Once our excludes are there, we can use our include, which is our source data where our snapshot is mounted. And then we will provide the -F flag for file, and we'll put the destination and file name for our backup file to output to. Then we'll do to, and we'll output any standard output errors out into temp/bkptar.log. So if there's any errors, they'll end up in that log file. Then I want to echo a line. We'll echo that the backup completed. And then we'll go with unmounting the snapshot and removing the snapshot. So for this, it's not that big of a deal that we don't check whether it was unmounted or not. We do want to check, but the next backup that runs will check for us. So we'll do an umount-rf, which is not a forceful way. It's a lazy way to make sure that unmount doesn't reject you right away with an error if it can wait for a time to unmount the directory if it's currently being used. It's just a more successful way to get a directory unmounted. So we'll umount-rf bkp, which is where our snapshot is mounted. We'll give it a couple seconds for it to unmount and the system to recognize that. And then we'll echo removing the snapshot. We'll take a look and see if our snapshot did get unmounted. And we'll do that using the df command like we did above. So if we find bkp in the df command, then we'll echo out the snapshot hasn't been removed yet, or it's still mounted. So snapshot still mounted, and we'll give it a couple more seconds. And then I'll just finish that there. We don't really need too much else. Like I said, the next backup will remove the snapshot if needed. So after sleeping for another 2 seconds through that if statement, we will attempt to remove the snapshot. And at this point, if the snapshot doesn't get removed, then we'll leave it and it will get removed on the next iteration of the backup, or when we log in, we'll get a warning. We'll create a very simple warning system later on. Okay, so now we want to echo out the date, which is going to indicate to us when the snapshot started. Then we'll do an ls to display the file that was created, our backup file. So we'll get an output of its size and its location, its permissions. Now, at this point, we are free to use SCP to transfer the file that we've created over to our remote destination server. So we'll create a little section here, transfer to remote server. And the command that we use is scp-i, which will allow us to specify a private key, the one that we created earlier. And that private key is located in /root/.sh/id_RSA. Then we want to specify the file that we are going to be sending, which is our variables, dest, and archive file. And then we will specify the username and server destination. I'm just going to do it by IP address. This server, it is local on my local area network, but we will change this later on. This is just to test this for the time being, and the server will end up being remote. Okay, and then we're going to get a colon, and we will put in the directory on the remote server that this is going to go to. So looking back at the tar command, we can see that we used the G option. The really cool thing about this is it's going to be an incremental backup. So the first backup we run will be the full-sized backup. It'll be much larger than the remaining backups. Then any subsequent backups will be much smaller and only contain changed files. And all of that information is held inside the bkp.snap file. All of the changed data and the files that we've backed up and stuff like that. So if we want to reinitialize an initial backup again, a full backup, we can simply just remove the bkp.snap file or rename it, and that will kick off a full initial backup again. So I'm just going to put a quick note up here at the top about how to restore these backups. Because they're incremental, you'll want to restore the initial base backup, which will be much larger, and then you'll have to restore each incremental backup after that. The command is quite simple, and to go through them would be quite easy. So if you have 7 days of backups that are incremental, the first day will be a large backup, and then you'll have 6 additional incremental backups. You'll have to run the same command on all 7 backups, starting with the first initial backup and then progressing up to the last incremental backup that you want to restore to. So the command is pretty easy. I'm just going to uncomment the line for now so that we can easily see what is being typed. So the command is tar -i and then pigz to indicate the compression algorithm or the compression application that was used, and then the regular tar flags, which is -xvf, and then you start with your base file first, and then you repeat for each incremental. Okay, so I think we're done with this, and we can write it out. Okay, so here we can see our backup.sh file, and then we want to make sure that we've created our BKP directory, and we also want to make sure that our mount/BKP directory exists, because that's where the backup will be going to. So let's go ahead and change the permissions on here to 770, which will allow the root user to execute the file. And let's give it a shot. Okay, so we see here that we have a syntax error on line 97. So let's move on over to there. It looks like we just left open an if statement. So we'll just check all of our if statements and make sure that they all have a phi to finish them. And I see here that this one does not. We missed it here at the bottom. Okay, let's try that again. Okay, and it looks like we have run out of space on our volume group to handle another snapshot. So it looks like actually the size of the snapshot that we're creating is too large for the volume group. So what we'll do is we'll remove this data logical volume that we no longer need. So let's go ahead and remove that. Even with removing that, that won't free up enough space in the volume group to accommodate a 20 gigabyte logical volume snapshot. So we'll just make it as large as we can given the constraints of the volume group. So we have 19 gigabytes free for our volume group. So I'll make the snapshot 18 gigabytes, which should be sufficient for the backup that we're trying to do. The backup is usually only less than 3 gigabytes. Okay, so let's try that again now that we've modified that and see what we get. Awesome, logical volume created, snapshot found, it's mounting it, and then let's wait for our backup to complete. So this initial backup took under 2 minutes. Okay, and we see here that we get a warning that the identity of the file used is not accessible. So we have a syntax error in the directory there. I can see we have a dot instead of a slash between .ssh and id_RSA. So let's jump back into our script and we'll correct that. So I'm just going to go to the mount directory and I'm going to remove these files so that our initial backup can be redone. I don't want to have the BKP snap or the backup file. I want to rerun this as an initial backup. And it looks like we got pretty good compression, 1.3 gigabytes on the backup for a logical volume that is 8.7 gigabytes. And probably about 3 of that is a swap file. Even then, this is still pretty good compression. Even if we only had 4 gigabytes of actual data, to get it down to 1.3 is pretty acceptable. Okay, and I also realized that our directory may be incorrect here for the destination. So I believe it's just backup. So let's give this another try. Okay, perfect. Backup completed. Unmounting the snapshot. The logical volume snapshot was successfully removed. Oh, and it looks like SCP failed with the directory is not found. So let me double check on the directory here and make sure that we get the correct directory for the remote destination server. Okay, so it looks like I was wrong again on that. So let's edit this and we'll change the directory to the correct one. It is in fact backups/backup. Let's try this again. We'll remove our backup file and our bkp.snap file and we'll rerun the backup. Okay, perfect. Backup completed, and it successfully completed the transfer. And just 1.2 gigabytes. Okay, so we can see here. So here's our file on our destination TrueNas server. So let's try running this again, and we'll see how large the backup file is the second time around as an incremental.
So we can take a look here. Here's our mount point. So the backup will take a look at the bkp.snap file, and when we run the backup again, it will reference that to get new files. So we'll see here that is much faster, and the file is much smaller, only 4.6 megabytes. So now the incremental backups, instead of taking about a minute or a minute and a half, they take about 10 seconds. Total round trip time. So now let's test to make sure that our snapshot detection works. So what I'll do is I'll start the backup and then I'll cancel it midway through before it gets to the point where the snapshot is removed or unmounted. So it's canceled. So now we can see here we have our backup snapshot in LVS, and we also have it mounted in DF. So when we run it again, we should detect that it was there and attempt to remove it. Okay, so it looks like it's running pretty good up until this point, and we can see an issue with our awk command. So it looks like we have a syntax error there. So let's take a look at the awk command and see what the issue with that is. Okay, so here's the issue. There's an ampersand sign here instead of a dollar sign. Let's switch that over to a dollar sign. And let's run this back up again. Okay, so run into another issue. It's attempting to remove the snapshot, but it's not removing it. So the snapshot remains, and there's no free space on the volume group to issue another snapshot. We'll have to take a look at the script and see why that is occurring. So the mount point isn't mounted, and it's still failing to remove the snapshot. So let's take a look again at our script and see what we're missing. So if we read our outputs, we see that it gives us an indication that it is proceeding. So this is the echo that we get to, no previous snapshot found, proceeding. And it looks like we did not add our statement here to remove the snapshot. We're in this if statement because we detected a snapshot, and we went through the whole process above to see if it was mounted. And at the end, in the else statement, meaning that there was no snapshot currently mounted, we're supposed to proceed with attempting to remove the snapshot. So let's change that from proceeding to removing snapshot, and then we'll add our lv remove command to remove the snapshot. And we'll just borrow the line from above. That should be good enough. And let's attempt it again. Okay, perfect. So no previous snapshot found, removing snapshot. We'll change the syntax for that to no mounted snapshot found. So we'll just quickly modify that so that our output to the screen is correct and meaningful. So I'll just change it to snapshot not mounted. And removing snapshot. Okay, now let's test that again. Okay, so it started the backup and we canceled it before it could remove it. So we have a snapshot and it is mounted. So let's test it and make sure that it removes the mount point and removes the snapshot properly. Perfect. Snapshot mounted, it's unmounting. Snapshot's unmounted. The snapshot was successfully removed. Okay, we're verifying it was removed, and then we're starting the backup. So this is the new snapshot that was created. And then the snapshot was found and it's being mounted to /bkp. Our backup completed. And then we're going to go through unmounting it, and then removing the snapshot, and then heading to SCP to send our new backup file over to the destination server. Awesome. Okay, and then we can see here all of our incremental backups. They're all about 4.5 megabytes. So now we want to be able to get a warning if we log into the system where a snapshot had not successfully been removed, and we want to be able to take care of that. So let's exit out of the root user, and we'll head on over to our home directory for the Techworks user, which is the primary user that we log into the system with. And the file that we're going to modify here is the .bashrc file. This is just a script that whenever you log into the system, it runs. So at the end of this script, we'll add our additional statements to indicate to us that a snapshot exists and that we might want to take a look at it. Okay, so what we're going to do is we will create an if statement, and we'll just check the devices for the snapshot file with the snapshot name that we have been creating. So if ls, and we'll ls dev /Ubuntu VG, and then we'll grep for the snapshot name, which is going to be bkp snap. And if that is there, then we'll echo out a warning, and we'll echo out the backup snapshot left behind. So when we log in, we'll get this warning. Okay, and I also want to add some color for this so that it stands out a little bit more. So we'll set the color on the echo, and we can do that with a command tput. We'll set the AF for the foreground as 1, which is the color red. And then at the end, we'll set it back to the default color. So we'll do the same command, tput set AF. Actually, this one is just going to be a reset, so SGR 0. So if the snapshot is remaining, we'll get a red warning. If it is not there, so else, we'll set the line to green, and we'll just say that the backup service is okay. So let's try and log in with a new login, and we'll test to make sure that this works. Okay, so there's our warning that we got. We got a little bit of extra information above that with the snapshot name, which is unintentional. So let's edit that little script again, and hit output because we forgot to direct the output of this command out to dev null. So we'll forward it out to dev null, and that should finish off this. Okay, we'll try logging in again, and we should get the warning again because the snapshot still remains. Perfect. We get our warning in red. Okay, so let's try and remove this. Okay, so there's our snapshot. Let's remove it. Okay, and we'll try and log in again. Now that the snapshot's removed, we should get a green line that says the backup service is okay. Perfect, and there it is. Okay, so now the last thing that we want to do is we want to add this backup service to our cron tab. So let's jump into cron tab -e. And here we'll add our cron job. So I'm going to run this at 4 a.m. of every day, every week, every month. So it's going to be a daily backup at 4 a.m. So to do that, we're going to do star space 4 space star space star space star. So it's going to be 0 for the minute, 4 for the hour, star for every day of the month, star for every month of the year, and then star for every day of the week. And the command is just going to be a /backup.sh is the command that's going to run, and that should do it for us. Okay, and that should do it. I hope that this backup script helped you understand how some scripting works and how the backup solution works. If you have any cool ideas or any changes that you would like to see in this backup script, leave a comment below and maybe we'll implement that. Thanks for watching. Bye.